Alright, if you still remember, we do l6v3, more questions to practice, alright, on stability of a digital signal. If you never watched that, I suggest you watch this first before we continue. Alright, so this is related to the questions posed in that video. Alright, is that I'll quickly go through is that over here this is your signals. I will assume that you already know. Alright, so this is your UK -1 and UK -2. So in other words, this is actually one time step, this is actually the second time step. Alright, so in total, this digital signal UK is comprises of only one time step and two time step. So in other words, if you are talking about a particular signal, alright, UK -1 is over here, UK -2 is over here. So you are taking two of this signal to represent the third signal, which is our UK over here. Alright, so you are only using one and two time step to represent your digital signal. Okay, but however, for your digital signal, normally you aren't talking about only one time step, you are talking about multiple time step. For example, if you want to find UK over here, this is the point that you want to find, you will take UK -1, UK -2 all the way, alright, to UK minus infinity, alright, the time where you just started. Alright, you're gonna sum up everything in order to fully get your whole signal out. You see? So therefore, this question that we pose, alright, is only talking about two time steps only. Alright, so therefore, having a two time step system, if you were to calculate and calculate and calculate, alright, eventually you'll get this answer, 0.25. I should write properly. It's about 0.25 plus minus 0.487. Okay, and if you were to plot this plot in the z domain, if you still remember, for the z domain, you have to plot is within the unit circle. Alright, so 0.25 is actually very near this side. Alright, 0.487, alright, somewhere over here. Okay, so 0.487. So these are the conjugate poles of your particular signal. Alright, so it is actually within the unit circle, so therefore it is stable. Alright, so however, alright, if you are talking about a huge chunk of signals, if you are going into infinity points, alright, instead of only 2 points, 2 points is only these 2 points that you can form to get UK. Alright, now in order to form UK for the infinite side, alright, you're gonna take in all the information from the previous one in order to sum out to get your UK, to get your full digital signal. Alright, so so what we have determined for stability is actually determined for only these 2 points. Alright, but if you want to determine the full stability, alright, then you are talking about BIBO stability. Alright, talking about the full system. Alright, because what you input is stable, it's a bounded input, or you also want to be a bounded output. Alright, so in such of the case that happens, alright, this particular signal over here, alright, is actually BIBO. So this will actually determine whether are you BIBO stable or BIBO unstable. So by definitions, the condition is that if it is going, so if your values over here is infinity, or then it's BIBO unstable. If it's to a constant number, then it's considered stable. If is going to 0, then it's also stable. So the only problem is if it goes to infinity, then it's unstable. So this means that if you were to sum out, alright, so instead of having UK -1, UK -2, you have UK -3 minus UK -4 all the way to UK minus infinity. Alright, so you're taking a hell lot of information. So if you sum all of them up together, alright, your value should converge to a constant, or should be equals to 0. Alright, if it's not 0 or any constant value, which is or infinity in this case, then you're considered unstable. So I repeat again, if your BIBOs, if you sum everything, all the signals, all throughout all the time domain, or if it's going into infinity, then it's considered unstable. If it converge into 0 or a constant value, alright, then it's considered stable. But in our case, we aren't actually concerned of this thing. Alright, but I just want to raise the awareness, because in your answer you also need to determine whether is it BIBO stable or not. So over here, alright, you is considered BIBO stable. Alright, I don't know why is the criteria to consider a BIBO stable in this case. Alright, because we don't have any information regarding the information on other signals, right? K minus 3 all the way to UK minus infinity. Alright, we don't have any other informations. So therefore, what criteria is considered stable, alright, is that for if it happen that your real, alright, is a very small number, alright, and that your imaginary is, if happens that you are below 0.5 lah. Okay, that's what I assume. I may be wrong. Alright, but this is a criteria. Alright, it's not from the dictionary, but it's from what I feel is that from deductive reasoning, because this is 0.487 already. Alright, 0.487 is somewhere up here already, and it's considered stable. It's considered BIBO stable as what he returned. Alright, so therefore what we can say is that if happen that your values is lesser, if your real or your imaginary is lesser than 0.5, alright, then it's considered BIBO stable throughout. Alright, so if you're larger, alright, for example, this is the second question. Alright, same style, but you have a different values. You see it's 0.8 plus minus 0.6. Alright, so it is considered BIBO unstable as he has returned. Alright, so over here you can roughly gauge, alright, what is considered stable, what is considered BIBO unstable. So over here this is considered BIBO stable, alright, because it's less than 0.5. Alright, but that's why I say it's very subjective. I'll leave you to think about it. Alright, but at least I raised this awareness. Alright, so but and then another question is also, this is 0.4, this is 0.7. As you can see, one of it is actually above our criteria of 0.5, so it's also considered unstable. Alright, so the takeaway in overall system is that you need to determine stability of your signal. So over here you can determine that it is stable for your 2 time step signal, so 1 time step and 2 time step. So for this 2 time step, they're actually stable. Alright, you also need to determine whether are they BIBO stable or not. Alright, so BIBO stable, you're gonna talk about a bit of a criteria, and I would assume that it's 0.5 somewhere. Alright, this is something that I pop it out myself, alright, from this deductive reasoning. Okay, and therefore likewise over here also, you see 0.8 and 0.6. If you take a look, 0.6 is awesome. So for example, this is the unit circle 1, 0.6 is somewhere over here. Alright, 0.8 is somewhere over here. Okay, so the 2 poles is somewhere, or the 2 roots is somewhere over here. So it's still, so it is stable for only 2 time step, but it's not stable if you are talking about all the way to infinity. Alright, if you're talking about many signals, alright, then it's considered BIBO unstable. Or BIBO is bounded input, bounded output. Because if the bounded input, bounded output, if happen that you don't understand or forgot, is that you have if you input a bounded value, so if you input 2, or you input 3, you input any bounded values, alright, you want to get a bounded output, right? Because you already bound your input as certain values, maybe less than 5, or maybe 4. So you set the value as a constant input, so you have bound it as a constant input, or you can bound it as a value that is smaller than 5, things like that. Alright, so you want it to be bounded. So if you input bounded input, you want your output to be bounded within a certain bounded values. Alright, but however, if it goes to infinity, you sum everything up as we have seen in the digital domain, because you are summing out every signal. Alright, so the summing actually will cause your system to go to infinity, alright, which is not bounded anymore, right? So therefore this is the reason behind to specify two stability. One stability is to specify the 2 time stack signal, which is the question is asking. Alright, you also need to specify whether is it BIBO unstable or stable. Okay, so it's gonna talk about when you sum everything up together. Instead of just 2 time step, you are summing up all the time steps, alright, all the way to infinity. Okay, so I hope that this is all the way to infinity means that UK minus infinity. Okay, not this value infinity. This value infinity is when you sum everything up. Alright, you sum all the list of digital signal. If your magnitude is infinity, then it's considered unstable. So I hope that this is a fairly bit. Alright, so the keynote is that normally a question you need to specify the digital stability and also the BIBO stability also. So you need to specify two types of stability. Okay, and the criteria, I'll leave you to think about it. I may be wrong. Alright, this is coming from me, purely from me, so I don't know whether is it right or wrong. So shall see you in the next video for other stuff.